Hello, আজি আমি ফিজিক্যাল কোয়ান্টিটিজ ওপৰত ডিসকাস কৰিম যেটা আমি ফোর্স পঢ়িবলগীয়া আছে ফোর্স পঢ়াৰ আগত আমি ফাৰ্স্ট অফ অল ফিজিক্যাল কোয়ান্টিটিজ গম পাব লাগিব দেন ভেক্টৰছ কোয়ান্টিটিজ গম পাব লাগিব তাৰ পাছত আমি ফোর্সৰ কথা অলপ ভালকে বুজি পাম সেইকাৰণে মই ফোর্সৰ কথা আজি আলোচনা নকৰো ডিসকাস নকৰো we will discuss physical quantities today so এনেকুৱা হয় বহুত পঢ়াৰ পাছত বহুত ফিজিক্যাল কোয়ান্টিটিজ কি এটো গম নাপায় so it is very basic concept what is a physical quantity আমি physical quantity definition to এনেকে আমি মনত ৰাখাটো বেছি ভাল হয় so physical quantities are the quantities that can be measured by physical means let us take an example length it is a physical quantity it can be measured by scale it can be measured by meter scale or any other type of scales then another example time it can be measured by your watch so again area it can be measured by meter or scale or another type of scale so we have mass can be measured by spring balance or electronic balances these are the quantities that can be measured by physical means so these are physical quantities so we have thousands physical quantities and we need physical quantities we will encounter physical quantities in each and every moment we study physics so physical quantities are those quantities which can be measured by physical means okay now we have a question that if everything we encounter in our life is physical quantity no it is not so we have some things which are not physical quantities just like emotion human emotion happiness love hate angriness so these are the things that cannot be measured there is no instrument yet that can measure human emotion so these are not physical quantities okay now physical quantities are now again divided in two groups so one is scalar quantities another one is vector quantities so first of all on what basis they are divided we need to know on what basis they are divided on the basis of the concept that if the physical quantity need a specific direction for the proper explanation or not so first of all the scalar physical quantities are the physical quantities that don't need any specific direction for their proper explanation or complete explanation let us take an example of physical quantity time so time suppose it is 12 p.m. or 1 p.m. so we don't need any direction on which direction it is 1 p.m. on which direction it is 12 p.m. so it is just 12 p.m. or okay so it is a scalar quantity we explain the time with proper explanation complete data has been given but we don't need direction specific direction so these are scalar physical quantities physical quantity another example is for scalar quantity suppose we have to measure the mass of suppose this pen we have to measure the mass of this pen so it may be 200 grams approximately so suppose it is 200 grams we don't need to give a specific direction on which direction it is 200 grams so it is 200 grams okay all data has been given complete explanation of the mass of this pen has been given so this physical quantity which is mass does not need any specific direction for its proper or complete explanation so this is scalar physical quantities there are many scalar physical quantities you can say about length you can say about time you can say about mass you can say about volume you can say about area you can say about speed you can say about energy so many scalar physical quantities you can say not many thousands of scalar quantities exist okay another group is vector quantities physical quantities are divided into scalar and vector scalar has been already discussed now we are going to discuss about vector physical quantities so what is a vector physical quantity scalar physical quantity does not need any specific direction and vector physical quantities need so let us take an example of a condition suppose wind is blowing So for proper explanation of this thing, we can say wind is blowing with 2 kilometer per hour speed, but it is not completely explained. We need more data. What? In which direction? So this thing, wind is blowing with 2 kilometer per hour. It is not complete. We need direction. So we have to say from east to west or north to south. So direction is needed in some physical quantities. For the proper explanation, direction is needed. And these are the physical quantities which are known as vector physical quantities or vector quantities. The simplest, or you can say the first vector quantity we encounter when we started studying physics is displacement. So I think you have learned about displacement in previous classes or previous chapters. So displacement is nothing but it is a distance. Though all distances are not a vector quantities, but displacement is one of them, which is a vector quantity. So how to know properly about displacement? Suppose an object moves from A to B in a curved or in a zigzag, any type of way. Distance. What is distance? It is the measure of actual path. This is the measure of actual path. You can say length of the actual path. It is the distance from this A to B. Suppose we have distance, but we can do another thing. We can draw a straight line or shortest line from A to B. Obviously, this is a straight line in Euclidean geometry. So this is a straight line. We draw a straight line from A to B, and we call the length of this straight line is the magnitude of displacement. Now, what we have to do, we have to specify the direction, from which direction the object is moving. We know the object is moving from A to B, so the direction is from A to B. So we have the displacement. Now, what is displacement? It is a vector quantity. Okay, so please give attention to this point because every vector quantity is going to be described in this way. That way I am going to describe the displacement. So displacement, the magnitude of displacement, it is nothing but the length of the line A, B. So it is magnitude. Vector quantity got the magnitude. Okay. Now, what is the direction of this displacement? It is the direction of the displacement is nothing but from A to B. It is the direction of the displacement. So every vector quantity will have to describe in this two parts. First of all, magnitude. Okay, it's done. Then we have to define the direction, the specific direction in which it has moved. So this is the vector quantity displacement, and every vector quantity will be described in this way, like displacement is described. So we got scalar quantities and vector quantities. So displacement is the first vector quantity that we encounter in physics. Then we got displacement divided by time. I think you have studied about this. It is velocity. Then change in velocity, because velocity again is a vector quantity. It comes from displacement divided by time. So it is a vector quantity, no doubt there. So in the change in velocity divided by the time taken for the change is known as acceleration, and it is again a vector quantity. Then acceleration of the object and multiplied by its mass is known as the force. So we are going to discuss about force. You have the concept that pull or push are the forces. Yes, they are the forces. Pull or pushes are the forces. So what we actually want to know in higher classes, so we got previous concepts of Newton's first law of motion. So Newton's first law of motion says that an object will not change its velocity until we apply an external factor. So we got two parts actually. One is that if an object is in stationary state, it will be stationary state, and if an object is moving with a velocity, and it will move with a velocity. If you can look at the both part, that if it having stationary state, if it is in stationary state, it has zero velocity, so it will be in stationary state. That means it will be continue to have zero velocity, no change in velocity here. Again, if it is having a velocity 5 km per hour velocity, it will not change its velocity, that is 5 km per hour velocity. So summary is that an object will not change its velocity unless and until we apply some external factor or physical quantity. So I want to define force in a very beautiful manner. I think that force is a physical quantity which is responsible for change in velocity of an object. Force is the physical quantity which is responsible for the change in velocity of an object. So we can feel the force. We can feel the force relate to your daily life experiences. We can feel the force. I can hold this pain. We need a force to hold this pain, and the pain is now in stationary, but you can see the pain will fall because some external force is applied on the pain. It is gravitational force. So we will discuss about these forces. Now force, again, now I want to again clarify, force is something. Force is the physical quantity that is responsible for change in velocity of an object. Sometimes the change in velocity is significant, sometimes it is not significant enough. So force can be again divided into two groups, again two. One is contact force, another one is non-contact force. So I am holding this pain, so I have to contact, I have to maintain a physical contact with the pain. So it is a contact force simply. But the pain can be attracted by the arts without any physical contact. It is non-contact force, very simple. Pulling or pushing an object with our hands, with a rope, with a stick, these are the contact force. And pulling an object, suppose pulling an iron rod with a magnet, it is a non-contact force. There is no physical contact between them. So these are the contact forces and non-contact forces simply. So some examples of contact forces are elastic force is a contact force, frictional force is a contact force. They come into play when objects are in contact. But some examples of non-contact forces are, you can say, electromagnetic forces, simply gravitational forces. These are non-contact force. Okay, then we have to study about moment of a force or torque of a force. Here in your syllabus it is not deeply explained. Torque, again, it is a vector quantity. I don't know if it is explained there or not in your book. Torque is a vector quantity. It has a specific direction. So it is again known as moment of the force. Torque is nothing but it is moment of the force or torque. So torque is a vector quantity. It needs a specific direction for proper explanation. But so I think in a context, direction is not given too much importance here. So I will like to go with your context. Okay. So what is the torque? How torque works? So torque is nothing but something when something rotates. When something rotates, torque has to come. So I think I have said that for changing velocity, we need a force. Our force is responsible for changing velocity. And what is change in velocity? Change in velocity is nothing but it is acceleration. When there is a change in velocity, we got acceleration. To have an acceleration, there must be a force. Just like that. To have rotational motion, there must be moment of force. There must be a torque. Nothing can rotate without any torque. There must be a torque. There must be a torque, not force. Okay. Just like for acceleration, we need force. Like that, for rotation, we need torque, and torque is nothing but it is the moment of the force. So how torque is defined, I am going to talk about in the next class. So concept. So ekhini asila mana jikin kotha force or kotha physical quantities vectors or kotha. So ekhini alop relate koribo paisa boli bhabisu. Next class of my moment of force ba torque kotha discuss korim. So hoyto আজি মই পিছবেলালৈকে এইখিনি কথা কৈ দিব পাৰোঁ. আই থিংক মই এইখিনি যিমান পাৰোঁ ইমান চেষ্টা কৰিম পিছবেলালৈ ক'বৰ কাৰণে. ঠিক আছে.